Hello students, how are you all? Today we are going to start a new lesson. I want you all to open your books, page number 552. On this page we have the topic about light. What is light? You live in a world full of colors. Look around. All the colors you see are part of light. Light is a form of energy we detect with our eyes. You can see the colors around you. There are so many colors, and you can see the colors with the help of light. If light is not available, you cannot see anything. You cannot see the colors. What is light? Light is a form of energy. Light is a form of energy we detect with our eyes. It comes from, now these are the sources of the light. The main source is the sun. The other sources we have light bulbs, fires, and other sources. It can even come from living things like fireflies. So these are the sources of the light. Now we have Newton's prism. In the mid 1660s, young Isaac Newton wanted to learn about light and colors. So what did he do? One sunny day, Newton darkened his room. He darkened his room and then he made a small hole in the window shutter. The hole was just big enough for a beam of light to shine through. Now the hole was so small that only a beam of light can enter the room. So his room was darkened. Only he made a hole in his window shutter so that only a beam of light can enter the room. So Newton then held a glass prism in the sunbeam. Then he put a glass prism in the way of the beam. What is a prism? A prism is an object that separates white light into bands of colored light. A prism, it's a glass, it's a glass object. It separates white light into different colors. With his prism, Newton saw all the colors of the rainbow. So if you pass a sunbeam through a prism, so the white light will be converted into the rainbow colors. You can see the rainbow colors. So this happened with the Newton. The visible spectrum. Now, Newton was the first to show that white light is made of all the colors we can see. Newton was the first one who showed that white light is colored of all the colors that we can see. White light is a mixture of all those colors. These colors make up the visible spectrum. Now all these colors that we can see, they make up a visible spectrum. We now know that the visible spectrum is not only part of light. Now, if we talk about the light, so there is not only visible spectrum, there are some other spectrums also, like sound. Light travels in waves. The electromagnetic spectrum is the range of waves that make up light. The electromagnetic spectrum, it's a range of waves. It's a combination of all the waves that make up the light. Like if we see the picture below, we have the picture of, they have given one example. There is a picture, you can see the electromagnetic spectrum. Here you have radio waves, you have microwaves, you have infrared waves. So these all waves are included in the electromagnetic spectrum. Now on the next page, we have wavelengths and energy. The light waves in the electromagnetic spectrum have different wavelengths. Now, the waves which we have discussed before, the radio waves and the other ones, they have different wavelengths. Each wavelength carries a different amount of energy. Now, they have wavelengths, they have some amount of energies also. The longer the wavelength, the less energy it has. If the energy is more, so wavelength will be short. If energy is less, wavelength will be more. Wavelength will be long. The light waves, the light waves with the longest wavelengths are radio waves. Means radio waves, they have longest wavelength, so it means the amount of energy will be less. They have the least energy. Okay, they have least energy, so longest wavelength. Radio waves, longest wavelength, least energy. On the other end of the spectrum are gamma waves. They have the shortest wavelength and the most energy. Now again, the same thing, that the gamma waves, they have the shortest wavelengths, so they have the most energy. So all those waves that having more energy, wavelength will be short. Less, if they are having less energy, wavelength will be long. Now on the second column, we have light waves can be both helpful and harmful. Now light waves, they can be, some of them they are helpful, some of them they are harmful. Did you know that a microwave can actually uses light waves? So this is not good. Or that heat is really infrared light waves. Ultraviolet or UV. UV is the name of ultraviolet rays. Ultraviolet waves are dangerous and can burn your skin. So these type of waves, they are very dangerous. X-rays, X-ray waves help doctors see inside the body. So this is helpful. At the top of the page, you have the picture of a traffic signal. The red, see, the wavelength is very long. The orange, the wavelength is a little short, and the green, it is the shortest. So if we talk about the traffic signal, the wavelength of the red light, it's the longest, and the wavelength of the green light is the shortest. On the next page, we have how does light travel. When you turn on a light, the waves spread out in all directions. When we turn on a light, the waves of the light, they travel in all directions, they spread. They move in straight lines or rays. Light rays can travel through air, water, and space. Now, light can travel, it can travel through air also, water also, and space also. Now, what is refraction? Is the thermometer in the picture really cut into two pieces? Now, here we have a picture of a thermometer. It is dipped in some liquid, and when the thermometer is entering the liquid, we can see that it seems to be that it is divided into two parts. It is not coming straight. The lower part, the part of the thermometer that is in the liquid, it is moved away. It seems that the thermometer is broken. But actually what happens, it is not broken. Is the thermometer in the picture really cut into two pieces? No, it is not. It is refracted. What is refraction? Refraction is the bending of light as it passes from one medium to another, from one material to another. When the light moves from one medium to another medium, it is refracted, or it is a little bend away. It is bending. So when the thermometer, the upper part of the thermometer, you can see that is air. Okay, and here it's water or some other liquid. Uh, it doesn't seem to be water. It is liquid medium. This is air medium. So when the light is traveling from air, from lighter medium to a denser medium, it will be refracted. So that's why the thermometer look to be cut, but actually it is not cut, it is just refracted. It is because of the reflection of light. Light rays bend as they pass from glass into water. Refraction also happens when light moves from cold air into warm air. So these are the cases when light is bent or light is refracted. Light travels at different speeds through different materials. The speed of light is different through different materials. Unlike sound, light travels more slowly through denser materials. Through denser materials, the speed of light is very slow. Okay, through lighter mediums, the speed of light is more. At the point where light hits the denser material, it slows and bends. The point where light hits the denser material, as the example shown here of the thermometer, where the light hits the denser medium, it slows because it is entering the denser medium, and it bends also. Water is denser than air, so light rays refract where water and air meet. This I just told you that as compared to air, water is denser, so light will refract where it meets the water, where water and air meets. Now we have lenses. Here they have given two types of lenses: concave lens and convex lens. Now first, what is a lens? A lens is a tool that refracts light. A lens is a tool that refracts the light, that bends the light. Now we have a concave lens. A concave lens curves inward. Example is this one. This is the concave lens. It is curved inwards. See, from here also, and from here also. So that's a concave lens. Light bends outward from the center of the lens. See, the light is coming here, and then after it is striking the lens, it is bending outwards. It is bending outwards. So the rays spread apart. Glasses that help you see far away objects are made of concave lenses. Those people who are using glasses uh, for looking the things that are far away, they are basically concave lens. The other type of lens we have convex lens. Convex lens bulges outward. Take the example of a convex lens. Here you have a convex lens. See, it is bulging outwards. It is bulging outwards. See. So what does it do? Light rays bend inwards towards its center. See, the light is coming and then it is merging inwards. See, this one is the red one. It is merging inwards. This makes objects near the lens seem bigger. Reading glasses are convex lenses. What do they do? The things that are near to the objects that are near, with the help of convex lens, they appear to be, they seem to be bigger, like the reading glasses. When people are reading, they are wearing reading glasses. The words are in front of them, they are close to them, so the convex lens, they make the words seem bigger, and the person can read. So the reading glasses, they have convex lenses. Students, I am stopping the class here. From the next page, inshallah, we will continue tomorrow.